Hey, how you doing today? Mr. Hardy here. We are going to be chatting about absolute value functions and graphing them today. Now, quick thing before we get started on the notes. This is going to be one of those sections. I don't know if the graphing calculator is a necessity here. I'm going to kind of play with both and let you choose. But again, if you don't have a graphing calculator, we talked about way back at the beginning of the year that you can actually get this downloaded onto your Chromebook to help. I mean, like exactly the same thing. So I'm going to take a moment here and we're going to go check that out. So if you go to my website and you're on the main stream and you scroll and scroll and scroll all the way to the bottom, the Algebra 2 library is down here. And so we're going to click on that. And once we get to the library, you can either start the show and find it that way, because it's going to be here under TI-84 Emulator, or you can just scroll down to, I think it's the 9th one of these. And there'll be a link here to get you an emulator for Chromebook. And an emulator is just a fancy word of saying, hey, we're putting this on your Chromebook. Like exactly the same thing. Same buttons, same presses. You'll see what I see when I'm doing it on a calculator. So you can find it that way, or if you're working with your own Mac or Windows computer, you can get that download here. Now again, is it 100% necessity? No, but man, it makes it a lot easier. Okay. My favorite, if you're going for a phone type thing, is called Calculate 84. That has a lot of the same button presses as well. So if you want to go to the phone app instead of having to mess with a Chromebook, again, Calculate, not Calculator, Calculate 84 would be the way for you to go on that. So okay, let's get those back out of the way. Let's jump back into our regularly scheduled programming here. So absolute value, okay, on the graphing calculator. A couple of things to take note of, as it says here at the top. If we ever want the absolute value bars, okay, that is going to be found in the math menu. So let me come up here, right below alpha, okay, our math menu, okay, we want to, let me get out of the glare there, there we go. So arrow over to num, for which stands for numeric, and then number 1 is abs, absolute value. And then it'll show up, and whatever you type inside, okay, will be there, and then I can right arrow to get out of it. So here's how that's going to come in handy with what we're doing. If we're graphing the mother graph, y equals x, okay, y equals, I'm going to try and get myself out of the way here. There we go. If I hit y equals, if there's something there, okay, we can just hit the clear button to get out of there. And so we're going to do this absolute value. So again, we're going to go math, arrow over to num, get our absolute value. And again, this is always x. This one, x, t, theta, n, all that good stuff. So the absolute value of x. Let's take a look at the graph first. Okay, we get the V shape going. That's always going to be true with your absolute value graphs. It's never going to be just line, then it wouldn't be absolute value. Absolute value will get both. So let's see, besides just sketching it, what the numbers look like. So we're going to hit second in graph. That will always give us the table for these. And you notice something. You're like, hey, every single value on there, well, not every single. Okay. When I'm doing anything with an absolute value, okay, two things I want to find. Number 1, I want to find the vertex. Okay, the vertex is the middle of my graph. And the middle of my graph is going to be the point where I start to see a reflection on the left or right. You're like, well, how'd you know it was at 0, 0? Because if I look at the y's, check it out. 1, 1, 2, 2. I'm seeing the same numbers reflected above and below this point. That's where my V comes. This is where my vertex or the center of my graph is. Okay, so our vertex of a mother graph is going to be at 0, 0. Now that's not always going to be there. It's going to move some. We'll get to that and explain why. But here otherwise, I'm just going to start plotting some of those other points. So 1, 1, if I go this way, 2, 2, 3, 3. We don't have to go forever. Negative 1, 1, negative 1, 2. Okay, and we get this V shape, and don't forget your arrows. Okay. That's the graph we base everything off of. Now, when we go to name the transformations, okay, we're going to discover for a little bit here before I give you the exact way that we do it, because I want you to kind of see it before you just try and memorize it. So we're going to go back to our calculator. Now, with that x that's already in here, notice if I just use my arrows, I can start typing more things in there. I don't have to start completely over. And if you do, that's okay. It's not a big deal. So x minus 2. Let me come up here for a second. Minus. This is negative. This is minus. The calculator is very picky about that. So be careful. So x minus 2. Let's take a look at the graph. So what does it look like happened? What changed? Like the fact that it's a v didn't change. But now my vertex isn't at 0. It moved over. Well, where did it move over to? Let's look. So again, we're trying to find what's called symmetry above and below. So I'm going to kind of scroll down a bit. And when I start to see, ooh, same numbers above and below a certain point, that's where my symmetry is coming from. So here I look and I'm like, okay, so the center of my graph is at 2, 0. If I go and look at the graph again for a minute, there's 2, 0. There's where the v comes in, okay, my vertex. So from there, again, I just start copying. So 1, 1, 0, 2, negative 1, 3. And yes, we're going to learn a shortcut to this. Always going to be shortcuts to things. But I want to show you the way of understanding it before we start trying to shortcut it. If we don't understand it and then we try to shortcut it, it's not going to help us. So what happened to my vertex? Well, my vertex now is at 2, 0. So what happened? My vertex moved right 2, along with every other point. Okay, this point moved right 2, and so did this one, and this one, and this one, and the same going this way. Okay, that's something we got to start noticing. So if I do that same thing to number 2 here, maybe after this one you're going to start figuring out the pattern already, and we're going to be rolling. So again, I can come in here and just change this to +3. If you want to start over again, you can. You can pause me if you need to until yours looks like this. And we hit graph. And again, I see the V shape, same type of slope, but now it moved over here. Well, where is that? Well, let's see. All right, we're going to keep moving up and down until we see symmetry. Same numbers above, same numbers below, and y. 1 through 5, 1 through 5. What's in the middle? Negative 3, 0. Okay, so my vertex is at negative 3, 0. You starting to see the pattern yet? So what happened to my vertex? This is my original. This is where I'm at now. I moved left 3. Be making sure you're making notes of the transformation. Because again, like most things in math, there's going to be a pattern here that we're going to want to follow. Okay, let's do one more, and then we'll chat about how this is all going to work. So you're probably going to have it down. So one more. Now notice, different this time, in that the +2 is not inside the absolute value, it's outside. So I'm going to hit delete a couple of times here to get that part out of the way. And then make sure my +2 is outside. Huge difference. So I watch the graph. Ooh, now it shifted up. So I'm like, all right, let's see here. How am I going to get... Now, here's a new twist for us. It's not always going to be 1, 2, 3, 4, 5 that you're seeing. Sometimes, as long as the numbers are the same, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, I get into both places. So where is my vertex? My vertex is at 0, 2. Because I moved up 2. Besides that, I'm still only just moving 1 each way. And that's one thing we haven't talked about yet that we're going to talk about right now. Have you noticed when we've been doing this that as it moves, it's moving left or right 1 and up 1 each time? Up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1. So when we're graphing these, okay, what I like to do is I like to call this my air quote slope, Because when we think about slope, we think rise over run, which is true with these, but it's not the same in that it's not always just going to be up and right, because then I just get one line on all of these, and that's not what I'm doing. So when you're graphing these, okay, we're going to try and do a trick here on number 4 and do this without the calculator. Okay, you're like, wait a minute, we haven't seen this before, though. Let's think about it. -4 outside, what direction do you think I'm going to shift? When it was plus outside, we went up. So what direction do you think we're going with minus? Okay. Down 4. I put a dot. My air quote slope is just going to be the number in front here. Well, again, if there's no number, my air quote slope is just going to be 1, just like it is if it's y equals x. It's 1 over 1. So what does that mean? It means I go up 1 over 1, but I do it in both directions with absolute value. Up 1 over 1, up 1 over 1. And I get my V shape. I connect the dots, and it looks like my vertex is at 0, 1, 2, 3. Okay, now let's test this out. Is that really what it is? Let's see here. So y, again, minus, not the negative out here. All right, let's see what we get. Shifted downward, shifted downward. Let's pull our chart. Okay, let's see here. Oops, Hardy started going the wrong way. You're like, Hardy, what you doing? Hardy's doing all sorts of weird things here. I know 0, 4 is my middle. Okay, there we go. Sorry about that. So I see my same numbers, -3, -2, -1, 0, 1, under both. There's my vertex. At 0, -4, I have my symmetry. And all of my points will match up. Okay, so here's the general theme of what we're doing here. Okay, let's put this all together. We're going to go back up to the mother graph for a minute. Okay, when we're graphing, I'm going to expand this a little bit. Okay. Now this is going to look crazy for a minute. Stick with me. You're like, whoa, what's going on with all of that? This is going to take in all of our transformations that can happen with our graph. And this is going to become a formula you're really familiar with, actually, as we go. Okay. A is always going to be my air quote slope. Whatever number's in front is telling me how much I need to go up, or in some cases down, which we'll talk about in a minute, and over. Okay. But air quote, because it's not true slope. We're not making lines here. We're making B's. Okay. This H is whether I'm going to move my graph. I'm going to shift it. I'm going to transform it to the left or right. Okay. So here, if it's plus, we're going to go left. If it's minus, we're going to go right. And keep this stuff handy when you're doing your assessments, when you're doing your practice, so you can get that reminder until you're feeling comfortable. And then the plus K on the end is my up and my down. Up is plus, down is minus. Now, some of you may be wondering, well, wait a minute. Up is plus, down is minus. That makes sense. Why would left be positive and right be negative? Isn't left negative and right positive? Yes, but this is X opposite of H. That's what this minus stands for, the opposite of what you would normally think. And that's why those work that way. So that's the one thing we got to keep an eye on with this, to make sure we don't get sucked in. But the calculator visually will help us with that as well. So, okay, we'll keep that in mind. And I'm actually going to put that on a sticky note quick so we can make sure that we are at all times going to have that with us. So let's see here. Almost set. Okay. So back into the grind we go. So I look at number 5 and I'm like, okay, what do I notice? My air quote slope is negative 1 over 1. Okay? Because that negative stands for negative 1. I don't have any move to the right. I don't have any move to the left. There's no plus or minus over here. So my vertex doesn't move. My mother graph was 0, 0. So go to 0, 0. But now since my slope is down 1 over 1, both directions, so from each dot, you keep going down 1 and over 1. Down 1 and over 1. Got to keep that V shape going. So all this really is, and I'll show you on here too. Oops, I wiped everything out. Now that is negative x, not minus. So negative. Negative. Okay. And again, to get our absolute value back up, because Hardy boneheaded, erased it. So math, num, and number 1. And we just want the x. And I see my graph, just like the mother graph, except it's reflected about the x-axis, okay? Let me put that terminology in here. Reflected about the x-axis. Okay, if you're asked for a transformation and there is a flip, okay, in generic terms, yes, we're flipping it, but we want to be mathematical here. We want to use the mathematician's language, which is reflected. Why do you say reflected? Because it basically took a graph that opened up like this and flipped it, reflected it, okay? So whenever you're seeing words in the summatives or places, it's going to say reflected about the axis when there's a negative here, okay? Again, you got it here for help. Make sure you're using the help. So that would be my transformation on number 5. Now number 6, I look, my air quote slope is 3 over 1. Do I have any shifts left or right, up or down? Nope. When we don't have any shifts left or right, up or down, my vertex is at 0, 0. And my air quote slope being 3 over 1 means I go up 3 and over 1. And again, I do it in both directions from every dot. So here, up and over. Up. I ran out of room, but I'm going to make this work. And over. Get my graph in. Again, just so we can kind of see it with the technology as well. All right, I don't want that negative anymore, so I'll hit delete. I do want, though, a 3 in front. I don't know if this is going to work. Nope, got to do it again. All right, let's start over. 3, math, numeric, absolute value, x, graph. So same V shape, okay? It's skinnier, though, okay? Sometimes there's different words that the mathematicians use for this too. Let me pull up the chart so you can kind of see here. Okay, there's my reflection. 1, 3, negative 1, 3, negative 2, 6, positive 2, 6. Okay. Okay, sometimes we'll call this a stretch. Okay. If it's expanding, or if it's a fraction and it's actually getting skinnier, we still call it a stretch that we're doing by that value, okay? So we got up, down, left, right, and then we also have our stretches, okay, or our reflections. So there's a lot of things we're trying to keep track of here. A little bit of a chunkier section here. We can take it in pieces. So here again is our absolute value function. Our vertex, okay, is going to be at HK. Now we saw here that if there are no left or right or up or down shifts, that means it's 0, 0, because I don't see H, I don't see K, we assume there's 0. And then the slope of my branch is the A value. So let's see if we can kind of start whipping some of these out a little bit more here and see if we can do it without even having the calculator, because that makes our life easier and a little bit quicker. So here I look and I'm like, okay, do I have any left or right, up or down? Nope. My only thing here is that I'm going to stretch it by 2. So if I stretch it by 2, my vertex is going to be at 0, 0. No left, right, no up, down. If I wanted to rewrite this, if you're a creature of habit, you're like, I want them all to look like this. Okay. Well, if you don't see values in a place, you can plug zeros in there. Okay, that's the same thing. So now my stretch, my slope is 2 over 1, because slope's always a fraction. Up 2 and over 1. Up 2 and over 1. And we do that in both directions. Okay. And again, you can type this in on your calculator and get the points from the chart if you need to as well. Now, I haven't forgotten domain and range down here. I just want to do one more graph first, and then we'll do the domain and range here. So question, which direction are we going 3? I know you have it up on the top of the screen, but you don't have the little notes. Might want to put little notes on yours there too. We're going what direction 3? Hopefully you've said right 3. So if we always start at 0, 0, and then we just follow the shift, right 3, we're right here. So my vertex, since I moved right on the x-axis, would be 3, and I didn't go up or down at all. 3, 0. My slope is 1, or 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Draw my arrows in. So for the first few times you're having to double check on the calculator, that's okay. That's not a big deal. But you do want to make sure that you're getting those in well. So now, domain and range. Okay, not something new to us in that we don't know what it is. It's just a different graph we're looking at now. So a couple reminders. Domain is my x values going from left to right. But whenever we see arrows, arrows mean infinity. Okay? Arrows equal positive or negative infinity. So when I'm looking at x, I'm like, okay, furthest to the left. Oh, look at that left. Forever left. Okay, what about right? Oh, keep going for the first. Oh, here we keep going. More arrows. Forever to the right. Sorry if I'm making your dogs bark with my pitch at home. I'll try not to do that all the time. What about range? Okay, range. Y. Bottom to top. Okay, where's the lowest point of my graph? The lowest point of my graph is right here. What is the y value right here? 0. What's the highest point? Up, 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 forever. There's even going to be a hint or a quick shortcut to this too, but we got to get a couple done before we can see it. Okay, so number 8. I look again. I'm like, okay, I got that one to kind of use as my example here. So left, forever, right. Oh, hey Hardy, does that mean that every single absolute value that I do graphically, the domain is going to be negative infinity to infinity? It is, okay? Every time that you're doing absolute value, okay? Easiest problem you're going to see on these. Now, let's see if we can find a pattern with y. So bottom, what value am I going to use? Be careful. It's not 3. 3 is on the x. According to the y value, it's 0. Up forever. You're like, is this going to be 0 up forever? No. Dang. Thought we had the whole pattern taken care of here. After you see the next one, I think you're going to know the pattern on range. Because notice, what have we done so far? Okay, we've moved right, it didn't affect the range. We've moved nothing, we stretched. It didn't affect the range. What affects the range? Well, let's see. Oh, fractions, don't freak out. No worries. Okay, what do we got here? What's the plus 4 represent? Up 4. We're going to stretch by a half. Okay. Now, the stretch won't change my vertex. Up and down does. Up 4. 1, 2, 3, 4. My vertex didn't move left or right any. 0. And up 4. Okay. My slope is a positive 1 over 2. So what do I do? Up 1 and over 2. Up 1 and over 2. And unfortunately, I ran out of room on this one, so that's all I'm going to have to work with. But what it does is it stretches out, it expands. The smaller the number, the more it expands. The bigger the number, the more it shrinks. Okay? So what we do here now is we go, okay, so what's that mean for me as far as domain and range go? Domain, we already talked about this. It doesn't matter. Forever left, forever right. Okay? So we've stretched it, we've shrinked it, we've shifted it. Doesn't make any difference. Range, though. Okay? Where's the bottom of my graph? Right here. What's the y value right here? 4. Goes up forever. So what changed between this one and the last two that we did where the range was 0? We had an upshift. Okay? So here's the rule. My range changes with an up or a downshift. As soon as I know what the shift is, if it's up or down, my domain's going with it. It went up, so did my range. If it goes down sometime, so will my range. Okay? So when we're doing the absolute value ones, that's the one you're really focused on. Is it going up or down? Because that's going to make a difference. Oh, let's do a double dipper here. Okay. Sticking with me. If you need to pause me and go get a beverage or some snack, that's okay. I'll still be here. Okay, what are my two shifts this time? Yes, you need to be talking to yourself out loud at home on this one. Speak out. I don't even care if you're in class. Say it. Hopefully you weren't staring blankly just at the screen right now. Left 2, up 1. Plus is left, plus is up. So if I start at the origin, and I go left 2 and up 1, where am I? I'm at -2, +1. Okay? The shifts go right with where your vertex is going to go. And again, you could find this as well if you were doing it on your calculator. Just find where the symmetry is. Here, I'll show you one more time on this, just so you can kind of see how this works. So x plus 2 plus 1. Okay, if I look at my chart, again, I need to see the same numbers above and below. So you're like, okay, now you know where it's supposed to be. So you get that value in the middle where you think the vertex is, and what you should see is the same numbers above and the same numbers below for y, and you do. So that's kind of your way of doing a double check if you need to with these. My slope is 1 over 1 because I don't see a number in front here, so we assume it's 1. Up 1 over 1, up 1 over 1. In both directions. And now we just do our thing. We know this one already. I don't even have to think about that. Okay, range. Here's where we start figuring out if we get this down. We see it goes up forever. I get to do the easy part. Where do we start? Right here. Y value of 1, which matches any up or down shift that I have. Okay? It's going to be like anything else. It's going to be about practice and just knowing what those shifts are and what they mean. But this form right here, is going to keep coming back over and over. When we're doing radicals, it's going to be there. Absolute value, it's going to be there. When we do parabolas in our quadratics unit, it's going to be there. So we got to get that locked in. Some of you are like, holy moly, this never ends. We just want to make sure you've got it. Actually, let me do you a favor. We're going to go to number 12. Because this kind of catches everything. You're like, holy cow, dude. All right. First things first. Two chefs, talk to me out there in virtual land. Left 3, up 7. Left 3, up 7. Left 3, up 7. They all go together. Okay, my slope, oh boy, is negative 2/3, which means what? It means my graph is going to open down. That's what the negative tells me. Okay, so all sorts of information here. The negative can go on either number, but only one. Okay, I usually just put it on the top number. So down to 1, 2, 3, down 2, 3, down 3, down 2, 3. Symmetrical fraction, so it's getting wider. Okay, again, the smaller the value, the wider, the bigger the value, the skinnier. Now let's lock this in. Domain, you know it. Okay, range, be careful. Okay, reminder, bottom to top. We're not starting with the number this time. Why? The arrows are going down forever. That doesn't make a difference on domain because it's left and right. Okay? Range, it matters because my bottom is negative infinity. We're going down forever. Here is my top point. What's the y value? 7. Why? It matches the up-down shift. Okay? We've got to keep working with those. It's the same thing every time. The shifts tell us our vertex. The slope tells us how many to go up or down and over. And any up or down shift tells us if we're going, what direction we're going. Okay? Funny feeling this is probably going to show up in one of our meets someday in a poll question or a quick quiz that we do sometime. Just saying. Just saying. Okay. One more piece. We are going to do a lot this year of working backwards. So we just got done taking equations and turning them into graphs. Now we're going to take the graphs and turn them back into equations. So to do this, okay, I'm going to write down our You're like, okay, so why do I need all this? For me to figure out what this graph is, okay, I need 2 bits of information. For me to do the equation from the graph, I need to know the vertex and the slope. And I can get both of those things from the graph. So I always tell people, write those 2 bits of information down first, then let's plug them in. So here's the deal, okay? Here's my vertex, right here. There's my H, there's my K. Okay, so step 1 done. Step 2, what's my slope? Well, how do I find slope? What I'm going to do is I'm going to find points on my graph, if they're not marked for me, that go through kind of like what I call the crosshairs, okay? Like this isn't going through crosshairs, that's just a random place. But if I'm looking for where they're going through those intersections, what I'm going to do is I'm going to count. I'm going to say, oh, it's going up, so it's positive. What's it going up? It's going up 2 and over 1, okay? The sign is determined by up or down. If it's up, it's positive with my A. If my graph is opening down, it's negative. Don't say this is up 2 and left 1 and make that negative. That's not how we do it. look at the picture and let it tell you right away, is it positive or negative? So once I have that info, now I'm ready to make my equation. Okay, my A is 2, or 2 over 1 if you want to do it that way. X opposite of H, the opposite of 2 is negative 2 or minus 2. Plus K means just keep this number. If I want to take a second to check, I don't have to do this, but I can. Oops, got to start over. Okay. 2 math num absolute value x minus 2 minus 2. Okay, let's see if my graph looks like that one. Vertex is down to the left. They open up. Looking good. I feel good. My equation is right. One more time, and you have survived. Okay? Again, have this as reference. If you need to go back and look at something, that's okay. Okay, so 1. My vertex, be careful. This is my vertex here. Just because I'm seeing numbers doesn't mean I got to use them. So there's my H and my K. And then my slope, okay? Opening downward means it's negative. I go to get from one point to either of these, it doesn't matter which one I use, I go down 2 and over 1, 2, 3. 1, 2, 3. Again, the negative comes from the fact it's opening down. That's all I need to know. And so from here, y equals A x opposite of 2 is minus 2 plus k. And I'm good. Okay. So here, now that you've got these, again, for today, it's just dealing with some of the practice graphing. You're naming the vertex. You're naming the transformations, the shifts, up, right, up, down, left, right, and your domain and range. Okay, again, start with the positive. Start with the evens or the odds. See how it's going. If it's good, great. You can stop. If it's not, try a few others. And then that last one on here shows a little bit later in the week, I think. We broke these up. But again, whenever you do it, identify the vertex and what the transformations are. Okay? Oops, I put 2 of the same one in there. I don't think you got to do it twice. So that's it for now. Again, as always, if you have questions with the technology or just what some of the generalities, let me know. But try it with these first and try it with your notes and see how it's going. Have a great rest of your day.